All right, so these problems are about compound interest, and all these problems are, again, things that I'm sure you've seen before in the past, but now that we know logarithms, we can actually use logarithms to solve other features. So the formula we'll need to solve all these is the amount of money, or at the end, how much money will we have, the amount, equals the principal, meaning the amount of money we started with, so meaning the beginning amount, and then we're going to multiply by 1 plus r, which is the rate, the interest rate we're getting on our money, and we have to write that as a decimal. It usually gives it to us as a percent, but we need to make sure it's written as a decimal. And then divided by n, which is the number of times the amount compounds in a year. So you'll see words like monthly, quarterly, semi-annually, things like that. So how many times is that in a year? Then to the power of nt. So it's the same n as the number of times it compounds. And then t is time, in years. So how long will it take? Okay? So that's the formula we need for this. So let's go ahead and take a look at number one. If you deposit $450 or $4,500, that's my principal. I'll put a P above it there. Okay, at 5%, okay, so that's going to be my rate. We'll try that again. That's my rate. And your interest compounded quarterly. Quarterly is the number of times. How much money will be in the account after 10 years? So 10 years would be T. So what we don't have is A, right? We want to know how much money it is. So we just simply plug it in, and we find out what it is. So it's going to be A equals, the principal was 4,500, 1 plus, so it says 5%, okay, but when we do 5%, the decimal's right there, we move it over 2 times to the left, or divide it by 100, and it's actually going to give us 0.05, so 0.05. So the compounded quarterly, so that means 4 times in a year. And then 4 to the, and then time is after 10 years, so 4 times 10. Okay, and simply, you just have a calculator and you figure it out. I'll kind of walk through the parentheses. Let's see what's inside. So 1 plus 0.05 divided by 4. I get, so 4,500 and change. This is 1.0125 to the 40th power. Okay, then I just go to the 40th power, and then I get 1.6436, but I want to leave all those decimals, because when I multiply by 4,500, it will give me the most accurate answer. And so I have an answer of the amount of money I'll have after 10 years is $7,396.29 if we're rounding. Okay, so that's how we kind of approach this problem. And again, a lot of you say, oh, I remember doing this, just simple plugging it in. But now, now that we know logarithms, that's how we're going to solve for things like time. Because you'll notice how time is up at in the exponent spot. And so what if we want to know what time is? Well, let's see here. Here we go. So if you deposit $4,000, okay, that's our principal, into an account paying 9%, okay, that's our rate. Compounded monthly, that's the number of times it compounds. How long until there is $10,000? So this time we're given A, but now we want to find T, okay. So this time we would write 10,000 equals the principal, which is 4,000, times 1 plus 0.09, because remember we got to change 9% into a decimal, divided by monthly, which is 12. There are 12 months in a year. And then to the power of 12t, because we don't know what time is this time. Okay? Now, the weird thing about this one is we actually have to get the parentheses that t is attached to by itself. So 1 plus 0.09 divided by 12. We have to get that parenthesis by itself. And there's that 4,000 in front that we have to get rid of first. So we're going to divide by 4,000, divide by 4,000, Cross off 3 zeros, cross off 3 zeros. 10 divided by 4, I think that's 2.5, if I'm not mistaken. So 2.5, and then we can do 1 plus 0.09 divided by 12. So 1 plus 0.09 divided by 12 gives us 1.0075 to the 12t. Okay. Now, in order to look at this properly, Mr. Schwant is going to move the 2.5 to the other side here because you're going to need your knowledge of logarithms to figure this out. So notice how my variable's in the exponent. I can actually rearrange this into a logarithm or put it in logarithmic form to solve for the exponent. And here's how it works. So this drops down. So it would be log base 1.0075 of 2.5, because as you know, these two things switch places, equals 12t. So now I actually have a logarithm, and notice how t is now almost by itself. We just have to divide by 12 to eventually get it. So in order to solve for time here, we have to do the logarithm up on top. And some people have a fancy calculator where we're able to do it, but I'll just use the change of base formula, which would tell me to do log of 2.5 divided by log of 1.0075. Okay, and then I get 122.63. And then I'm going to leave all the decimals because if I divide it by 12, it's going to give me the most accurate answer. It's going to take 10.22. So 10.22 years to get $10,000 in that account. Okay? So that's how much time it would take to do that. So there's two different kinds of problems. There's, okay, I give you the time and I give you the initial amount. What's the final amount? And there are times where the question will give you the final amount and it wants to ask how much time will it take. Okay? So make sure you pay attention to all those, and hopefully this helps out.